In March 2023, a homeowner in Stockton, California, woke up at 2 a.m. to the smell of burning plastic. By the time the fire department arrived, the entire sidewall of his garage was charred black. The source was not a kitchen fire, not a space heater left on overnight, not faulty wiring inside the walls. It was the electric meter. The utility's sealed gray box on the outside of the house had turned into a blowtorch. Investigators later found that someone had attached a metallic strip to the meter housing, a modification inspired by a viral video promising hundreds of dollars in annual savings on electricity bills. That homeowner story is not unique. Across the country, utility companies and fire departments have been responding to a growing wave of meter-related incidents linked to a single viral claim that a cheap zinc strip costing less than $1 can magically recalibrate your electric meter and save you up to $1,200 a year. The videos have racked up millions of views. The comments are filled with people swearing it works. And the narrative is always the same. A secret the power companies have buried since 1962, exposed at last by brave internet truth-tellers. Today on Oracle Prime, we're going to do something those viral videos never do. We are going to actually test this claim, not with hype, not with conspiracy theories, but with 200 years of electrochemical science, verified engineering data, and the cold, hard math that separates survival knowledge from dangerous fiction. And along the way, we are going to uncover the real electrical threat hiding inside millions of American homes right now, one that no viral video has ever warned you about. Let us get into it. What the viral videos are selling. Here is the pitch, stripped down to its core. The viral videos tell you that your electric meter, that gray box bolted to the side of your house, is systematically overcharging you. They claim that a natural layer of aluminum oxide builds up on the internal components of the meter, creating what they call a galvanic imbalance that makes the meter run between 8% and 12% fast. In plain English, they are saying your meter records more electricity than you actually use, and the power company quietly pockets the difference. The supposed fix is absurdly simple. Buy a zinc anode strip from a marine supply store for under $1. Clean a spot on your meter housing. Tape the zinc strip to the outside. The zinc, they claim, neutralizes the oxide layer through an electrochemical reaction, returning your meter to true accuracy. Your bill drops. You save $1,200 a year. To give this story scientific weight, the videos cite a professor named Dr. Raymond Howell at the Illinois Institute of Technology, who allegedly published a groundbreaking paper in 1962 documenting this exact phenomenon. According to the narrative, utility engineers read that paper, realized it threatened billions in revenue, and buried it in corporate archives for 6 decades. Now, brave whistleblowers on social media have finally set the truth free. It is a compelling story. It pushes every emotional button: corporate greed, hidden knowledge, the little guy fighting back with science and pocket change. But compelling is not the same as true. And before anyone tapes anything to a live electrical enclosure, we need to examine every piece of this puzzle. Here is what makes this myth so effective. It is built on a foundation of real science. The concept of a sacrificial zinc anode is not internet pseudoscience. It is one of the most important discoveries in the history of human engineering, and it dates back exactly 200 years. In 1824, Sir Humphry Davy, president of the Royal Society of London and one of the most celebrated chemists of his era, was hired by the British Admiralty to solve a crisis that was crippling the most powerful navy on Earth. The Royal Navy had been cladding the wooden hulls of their warships in copper sheeting to protect against shipworms, those tiny marine organisms that could bore through an oak hull and sink a warship from the inside out. The copper worked brilliantly against the worms, but there was a devastating side effect. The iron bolts and fittings holding the ships together were corroding at an alarming rate. Ships were literally falling apart at sea because two different metals were reacting in salt water. Davy identified the problem as what we now call galvanic corrosion. When two dissimilar metals sit in an electrically conductive liquid, an electrolyte like seawater, one metal sacrifices itself to protect the other. The more reactive metal loses electrons and dissolves. The less reactive metal stays pristine. Davy's solution was elegant. Attach blocks of zinc or iron to the copper hull. Because zinc is far more reactive than copper on the galvanic series, the zinc would corrode first, sacrificing itself to keep the valuable copper intact. It worked. 2 centuries later, every navy on the planet still bolts zinc anodes to the hulls of their ships. Pipeline engineers bury zinc anodes alongside underground gas lines to prevent corrosion in mineral-rich soil. Your home water heater almost certainly has a magnesium or aluminum sacrificial anode rod inside the tank right now, slowly dissolving to protect the steel walls from rusting through. This is proven vital science. And this is the kernel of truth that the viral videos exploit. They take a real electrochemical principle, one that has saved countless ships, pipelines, and water heaters, and stretch it across a chasm of missing logic to reach a conclusion that does not hold. Why it cannot work on your meter. If you have ever built a campfire, you know the fundamental rule. You need 3 things: fuel, heat, and oxygen. Remove any one of those 3, and you do not have a fire. You have a pile of cold sticks. Galvanic protection works the same way. For a sacrificial anode to protect another metal, you need 3 components present simultaneously. First, an anode, the sacrificial metal like zinc. Second, a cathode, the metal you want to protect, like aluminum. And third, and this is where the entire viral claim collapses, a continuous electrolyte. An electrolyte is a liquid or wet medium that allows ions to flow between the 2 metals, completing the electrochemical circuit. In the ocean, billions of gallons of salt water serve as the electrolyte. Underground, moist, mineral-rich soil does the job. Inside your water heater, the water itself is the electrolyte. Now look at your electric meter. It is bolted to the side of your house, surrounded by dry atmospheric air. Air is one of the best electrical insulators in nature. It is not an electrolyte. You can tape zinc strips to that meter housing all day long, but without a conductive liquid path between the zinc and the internal aluminum components, there is no ion flow, no electrochemical circuit, and no protective reaction, period. Think of it this way. Holding a zinc strip against a dry meter housing and expecting it to neutralize internal oxidation is like holding a match 3 feet away from a log and waiting for it to catch fire. The chemistry requires contact through a medium, and that medium does not exist in open air. But wait, what about those zinc strips people put on their roofs to kill moss? That is a question worth answering, because it reveals exactly how this myth borrows from real applications and misapplies them. Roof zinc strips work through a completely different mechanism. When rainwater washes over the zinc, it carries dissolved zinc ions down the shingle surface, and those ions are toxic to moss, algae, and lichen. It is a biological effect powered by flowing water, not an electrochemical protection circuit. And even then, the effect only reaches about 15 feet down the roof before the zinc concentration becomes too dilute to matter. There is no magical force radiating through dry air. Dr. Howell's missing paper. Every good myth needs an authority figure, and this one has Dr. Raymond Howell. The story claims he was an electrical engineering professor at the Illinois Institute of Technology who published a seminal paper in 1962 documenting how aluminum oxide buildup on meter components caused a consistent 12% over-measurement error in Westinghouse electromechanical meters. The problem is straightforward. This paper does not appear to exist. Searches through the archives of the Institute of Electrical and Electronics Engineers, the American Institute of Electrical Engineers, the National Institute of Standards and Technology, and various government assessment programs from that era turn up nothing matching this description. Papers on sacrificial anodes and cathodic protection from the early 1960s certainly exist, but they focus entirely on structural corrosion protection for marine and underground applications. Not one addresses revenue metering accuracy. This does not mean the claim was debunked by the establishment. It means the foundational evidence was never established in the first place. It is not a suppressed truth. It is an unverified story, one that conflates real corrosion science with the completely different engineering of utility meters to create a narrative designed for clicks, not for accuracy. What oxidation actually does to a meter, the physics nobody mentions. Let us grant the viral videos every possible benefit of the doubt. Let us assume, hypothetically, that the aluminum components inside an older electromechanical meter do develop an oxide layer. What would actually happen? Aluminum is a highly reactive metal, but its oxidation is self-limiting. When bare aluminum contacts air, it instantly forms a passivation layer, a microscopically thin shell of aluminum oxide that actually protects the metal underneath from further corrosion. Research into aluminum film oxidation shows this layer grows rapidly in the first hour, reaching about 10 to 12 angstroms in thickness, then slows dramatically and stabilizes completely within roughly 30 days at a maximum of about 22 angstroms. An angstrom is 1/10,000,000th of a meter. That oxide layer is thinner than the wavelength of visible light. On a meter disk several millimeters thick, it represents a change so infinitesimally small that it cannot measurably alter the bulk electrical conductivity of the component. Now here is the critical point that the viral videos get exactly backwards. The claim says oxidation makes your meter run fast, recording more electricity than you use. But basic electrical theory says the opposite. If an oxide layer increased the electrical resistance within the meter's internal connections, Ohm's law tells us that for a fixed voltage, current decreases. Higher resistance means lower measured consumption. Your meter would run slower, not faster. You would be undercharged, not overcharged. There is a theoretical scenario where reduced conductivity in the aluminum disc of an old induction meter could decrease the eddy current breaking torque, potentially allowing the disc to spin slightly faster. But that 22 angstrom oxide layer on a disc several millimeters thick simply does not produce a measurable change in bulk conductivity. The effect is so small that it falls well within the normal calibration tolerance of the instrument. Numbers do not lie, so let us do the math the viral videos hope you never bother to check. According to the U.S. Energy Information Administration, the average American household pays approximately $163 per month for electricity as of early 2026. That works out to roughly $1,956 per year. Even at the maximum claimed error rate of 12%, 12% of $1,956 is $235, not $1,200. To save $1,200 from a 12% error, your annual electricity bill would need to be $10,000, the kind of bill you see at a commercial warehouse, not a 3-bedroom house. For the average homeowner, even if the impossible 12% error were real, We are talking about roughly $20 per month. Nobody wants to lose $20 a month, but that figure is an order of magnitude smaller than the $100 per month the viral videos promise. Now, let us look at it from the engineering side. What would it take for terminal oxidation to actually affect your electricity measurement by 8% to 12%? The contact resistance at the meter terminal would need to increase significantly. Let us say it increased by just 0.1 ohms, already a very high value for a heavy-duty utility connection. In a typical residential load pulling 100 amps, the power dissipated as pure heat at that terminal would be enormous. 100 squared times 0.1 gives us 1,000 watts of heat concentrated at a single connection point. Imagine a space heater crammed into a connection lug the size of your thumb. That terminal would not quietly overcharge you. It would melt the meter socket, vaporize the insulation, and start an electrical fire within minutes. If the resistance was low enough to avoid melting, say 0.001 ohms, the voltage drop would be a mere 0.1 volts, representing an error of less than 0.1% on a 120-volt circuit. Not 8%, not 12%, less than 0.1%. The claimed error rate is not just unlikely. It is thermodynamically impossible without catastrophic physical destruction of the meter. Why none of this matters for your meter anyway. Even if every piece of the 1962 theory were true, the oxide layer, the galvanic effect, the spinning disk, it would be completely irrelevant to your home today. The vast majority of American households no longer use spinning disk electromechanical meters. They use advanced metering infrastructure, smart meters. Modern smart meters measure electricity using entirely different technology. They employ high-speed digital sampling, shunt resistors, and current transformers. A current transformer measures the magnetic field around a conductor without physically touching the current-carrying wire. It is completely immune to terminal oxidation. There is no spinning aluminum disc. There is no magnetic damping mechanism. The physical phenomenon that supposedly caused the error in 1962 literally does not exist inside your meter today. The real threat no viral video warns you about. Now, here is where Oracle Prime pivots from debunking a myth to giving you something genuinely valuable. Because there is a real electrical danger lurking in millions of American homes, and it has nothing to do with zinc strips. The danger is inside your electrical panel, the breaker box, that gray steel cabinet in your basement, garage, or utility closet that distributes electricity to every circuit in your home. If your home was built between the 1950s and the 1980s, there is a real possibility that your panel was manufactured by one of two brands that have been linked to thousands of house fires: Federal Pacific Electric, with their Stab-Lok breakers, or Zinsco. The core problem with these panels is terrifyingly simple. The circuit breakers fail to trip. When a short circuit or overload occurs, a properly functioning breaker snaps open and cuts the power, preventing wires from overheating and starting a fire. Federal Pacific Stab-Lok breakers were tested by independent laboratories under contract with the Consumer Product Safety Commission, and 51% of them failed to trip under overload conditions, more than half. Zinsco panels have a different but equally dangerous flaw. Over time, the breakers can fuse themselves to the aluminum bus bar inside the panel. That means even when a breaker appears to be switched off, electricity may still be flowing through the welded connection. You could be standing in front of your panel, thinking a circuit is dead, while current is still running through it. These are not theoretical risks. Industry estimates suggest that federal Pacific panels alone are responsible for approximately 2,800 residential fires per year. Insurance companies across the country have started refusing to write homeowner policies on properties that still have FPE or Zinsco panels installed. If your home has one and your insurance company does not know about it, a fire caused by that panel may not be covered. Here is how to check. Open the door of your breaker panel and look for any of these markings: Federal Pacific, FPE, Stab-Lok, Zinsco, Sylvania, or GTE Sylvania. If you see any of those names, contact a licensed electrician for an inspection. A full panel replacement typically costs between $3,500 and $6,000, but it can literally save your home and your family's lives. The real reason utilities tell you not to touch the meter. The viral narrative wants you to believe that power companies declared the zinc strip illegal because they are terrified of losing billions in secret revenue. This framing ignores how the utility industry actually works. Utility companies are not unregulated monopolies, free to pocket whatever they want. They operate under strict oversight from state public utility commissions, which mandate periodic accuracy testing of meter fleets. If a specific meter model was systematically running 12% fast, the utility would be legally required to replace every unit and issue refunds to affected customers. Furthermore, utility profits are typically capped at a specific rate of return on capital investments. Collecting 12% more revenue than the energy delivered would exceed that cap, triggering audits and federal investigations. It would be the corporate equivalent of robbing a bank and then depositing the cash into your own checking account. The real reason utilities tell you not to tamper with the meter has nothing to do with protecting revenue. It has everything to do with preventing you from killing yourself. The electric meter is a sealed, high-amperage instrument. The terminals behind that glass or plastic housing carry the full service current for your entire home, typically 100 to 200 amps at 240 volts. When you attach a metallic strip to the outside of that enclosure, you are introducing an unlisted, non-standard conductive element to a live electrical system. If that strip comes loose in a storm, if it slides behind the housing, if it bridges even a tiny gap between the grounded enclosure and a live, uninsulated terminal, you get an arc flash. An arc flash generates plasma hotter than 35,000 degrees Fahrenheit. That is hotter than the surface of the sun. It can blind you permanently from 10 feet away. It can launch shrapnel-like fragments of molten metal at ballistic speed. Trained utility workers wear full arc-rated protective suits and face shields just to remove a meter from its socket. This is not corporate fear-mongering. This is physics, and it is the reason every meter in America carries a tamper seal. Protecting what you have. The real science of electrical panel preservation. For those of you with modern, safe panels, the next question is maintenance. Corrosion inside an electrical panel is a legitimate threat, just not the kind the viral videos describe. Rust on breaker contacts, corroded bus bars, moisture intrusion through the service entrance. These problems are real, and they develop slowly over years in damp basements, coastal environments, or garages where road salt gets tracked in on car tires during winter. So how do professionals actually fight this corrosion? Not with zinc strips taped to the outside, with something far more elegant: vapor corrosion inhibitors, or VCI. VCI technology uses small capsules or adhesive tabs that you place inside the closed electrical enclosure. These tabs emit invisible, odorless, non-toxic vapor molecules that saturate the enclosed airspace and form a microscopic molecular barrier on every exposed metal surface: the copper wires, the aluminum lugs, the steel breaker contacts. This barrier prevents oxygen and moisture from interacting with the metal, stopping corrosion before it starts. The protection lasts up to 2 years per tab, depending on how well sealed the enclosure is. Because VCI works as a vapor, it reaches every crevice inside the panel without needing a liquid electrolyte. And because the tabs are made of inert plastic and chemical compounds, there is zero risk of them causing a short circuit if they ever come loose. A few honest limitations you should know. VCI prevents corrosion but does not reverse damage that has already occurred. If your panel already shows signs of rust or corroded connections, you need an electrician to assess and repair the damage first. VCI tabs work best in reasonably sealed enclosures. If your panel has large gaps or is mounted in a completely open-air environment, the vapor disperses too quickly to be effective. And in very humid environments, you may need to replace the tabs more frequently than the standard 2-year interval. For maximum protection, keep the area around your panel dry. If it is in a damp basement, invest in a dehumidifier. If your garage sees road salt in winter, clear the salt off your car before parking, or consider a garage floor drain. And always have a licensed electrician perform any work inside the panel. There is live, lethal electricity behind that cover. What actually saves you $1,200 a year? The viral videos promise $1,200 in savings from a magical zinc strip. Here is how you actually save that much. No myths required. Start with insulation. The Department of Energy estimates that sealing air leaks around windows, doors, and ductwork can reduce heating and cooling costs by 10% to 20%. On a $1,956 annual bill, that is $195 to $390 saved right there. Switch to LED lighting throughout your home. LED bulbs use 75% less energy than traditional incandescent bulbs and last 25 times longer. Replacing 20 bulbs saves roughly $150 per year. Upgrade to a smart or programmable thermostat. These devices learn your schedule and adjust heating and cooling automatically, saving the average household $50 or more annually. Replace aging appliances with Energy Star certified models. A new Energy Star refrigerator, for example, uses 9% to 10% less energy than the minimum federal efficiency standard. And here is one most people overlook. Check your utility rate plan. In deregulated states like Texas, Ohio, Pennsylvania, Illinois, and others, you can shop for electricity providers and potentially cut your per kilowatt-hour rate by 15% to 30% without changing a single habit. Stack these strategies together, and $1,200 in annual savings is not just achievable, it is conservative. No myths, no risk, no duct tape on a live electrical enclosure. "200 years ago, Sir Humphry Davy stood before the Royal Society in London and presented one of the most important discoveries in the history of chemistry: the principle that one metal can sacrifice itself to save another. That discovery still protects every naval vessel, every underground pipeline, every water heater in your home. But Davy's principle requires an electrolyte. It requires a conductive medium. It requires the right conditions. Strip those conditions away, and you do not have cathodic protection. You have a piece of zinc taped to a dry box, doing absolutely nothing except creating a potential safety hazard. The $1 zinc strip myth is a masterclass in how real science gets weaponized into misinformation. It takes genuine historical knowledge, the kind of knowledge we celebrate here on Oracle Prime, and twists it just enough to sound credible while being completely wrong. The physics of contact resistance proves that the alleged error would cause a catastrophic fire, not a quiet overcharge. The math proves the savings claims are fiction, and modern smart meter technology renders the entire theory obsolete. The power grid is not hiding a billion-dollar secret. They are trying to stop people from turning their electric meters into unshielded arc flash hazards, based on a video they saw between cat clips and cooking tutorials. The real lesson is this: survival in the modern era means protecting your home from actual threats, not imaginary ones. Check your breaker panel. Invest in proper corrosion prevention. Seal your windows. Upgrade your insulation. Audit your energy habits and your utility plan. That is how you take real control of your electricity costs. If this investigation opened your eyes, share it with someone who needs to hear it, especially any homeowner who might be one viral video away from taping metal to a live electrical enclosure. Subscribe to Oracle Prime. We are here to dig into the forgotten skills, the buried history, and the unvarnished truth that helps you navigate this complicated world. Keep questioning, keep learning, and never let a myth put your safety at risk. We will see you in the next one.